Shop the Plato's Closet Black Friday event in North Charleston and West Ashley and let the deals begin. You know Plato's Closet always has a huge selection of trendy recycled styles at amazing prices, but Black Friday deals are different. They're better. We've been holding back some of our best inventory, and you won't want to miss our Black Friday event. Save on gently used styles from Patagonia, Lululemon, Lilly Pulitzer, and hundreds of popular brands. Plato's Closet is ready to let the Black Friday deals begin. Plato's Closet, located in West Ashley on Sam Rittenberg Boulevard and North Charleston on Rivers Avenue.
Fargo, the new virtual assistant from Wells Fargo, makes banking faster and easier. Like this.
Fargo, what's my checking account routing number?
And this.
Fargo, turn off my debit card.
And this.
Fargo, what did I spend on groceries last month?
And that's just the beginning. Do you Fargo? You can. In the Wells Fargo mobile app. Learn more at wellsfargo.com/getfargo.
Terms and conditions apply. Your mobile carrier's availability and message and data rates may apply. Wells Fargo Bank, N.A., member FDIC.
Hello again. Thanks for joining us on Space Nuts, a program about astronomy and space science. I'm your host, Andrew Dunkley. We've got a lot to talk about today, including the biggest Mars-quakes ever recorded, which is very exciting news, even though we don't know why they're happening. We'll also be talking about the recent eclipse that was filmed by the Perseverance Rover. The winds of Mars seem to be having a very interesting effect on the planet. And something a little bit sad is the Artemis One project. They've rolled it back to the shed, the poor old thing. It's, back to the workshop. Plus some audience questions about what is the dust at the centre of our galaxy and what happens if the Earth stops spinning. That could be pretty scary. That's all coming up on Space Nuts.
15 seconds. Guidance is internal. 10, 9, ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining me, as always, is the good Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. I like your fan. It's a very elegant fan.
My one and only fan.
Yeah,
that has stuck with me for the last 8 years without fail.
Falling off the ceiling. Yeah.
I very rarely use it though. This is quite a cool room at the best of times. So,
that's good. That
looks very cool, in fact.
Yeah.
Much cooler than me. How's the weather down there, Fred? Are you getting more rain?
Yeah, we are actually. There's some more showers on their way down today. I just emptied the rain gauge from yesterday. It's nothing like it was a couple of weeks ago, only 10 millimetres, but it's still coming down.
Yeah, we've had a bucketing all night and it's still raining as I speak.
Okay.
So, yes, quite damp. We've had about 25 millimetres today, and that's about an inch in the old scale for the farmers out there that listen to us. And still, I don't know what it is in points. I've no.
Isn't a point 1/100 of an inch?
Something like that.
Yeah, so it's 100 points.
100 points, yes, that's right. I do recall now. We've got a lot to get to, Fred, so we better get stuck into it. Let's talk about these Mars-quakes. Now, we've talked about them before when they've been recorded, and they've basically said we know these things happen, but we don't know why. But now they've recorded the two biggest ever Mars-quakes, and these ones are actually getting up there to Earth-type standards.
That's right. If the Richter scale, as we know it on Earth, translates equally to Mars, they are defined as a magnitude 4.2 and a magnitude 4.1 Mars-quake. Yeah. And they're really interesting. But what's really special about them, Andrew, is that there's enough information in those, in the shuddering, that you can actually sense where they've come from. And they're the first recorded events to occur on the other side of the planet from the InSight lander, which is what has recorded them. InSight, of course, not a rover, a lander that was designed to give us insights into Mars's interior, landed there 26th of November 2018, has been working ever since. You might remember they had terrible trouble with the temperature sensor, and I don't think they ever got it to work because it was supposed to be hammered into the ground. And that's right. Yeah. But the seismometer has worked flawlessly. And so now it's picked up these events which are being identified as being, as I said, on the far side of the planet from the lander. And they're much, much stronger. apparently 5 times stronger than the biggest one that's been recorded before. Some of this science has come from the University of Bristol in the UK, and what they've done is they've identified waves which we're familiar with on Earth. And I'm going to put some technical terms in here because I think they're really cool. Earthquake waves, Andrew, come in 2 kinds, which are known as P and S waves. And the P waves stand for pressure waves. So they're a bit like sound waves. They're waves that, have a compression in the same direction as the wave is traveling, just like sound waves do in air.
So they would be the cause of tsunamis and things like that. Is that right?
I think actually both cause tsunamis on Earth. There's unlikely to be tsunamis, at least today, on Mars, although there's, just as an aside there is evidence, geological evidence from Mars, that there have been tsunamis in the past, which is really quite amazing when Mars had an ocean. So that's the P wave, the compression wave. The S waves are what are called shear waves, which are more like waves in a guitar string. It's going side to side rather than backwards and forwards. But these are actually something so they are pressure waves and shear waves that have been recorded, but they're actually defined as PP and SS waves. PP, of course, in music means pianissimo, which is very quiet, but actually in seismology, it's a pressure wave that has been reflected back from the crust, back down into the interior of the Earth normally, but here we're talking about Mars. So PP waves, pressure waves that have been reflected from the crust, and you might not be surprised to hear that SS waves have been, they're also shear waves that have been reflected back downwards from the crust, which gives them a longer traverse time. And that's, if you've got these reflections from the crust, so imagine a wave propagating through Mars's mantle, which is the layer underneath the crust, it bounces backwards off the crust itself and has a longer propagation path. It means you can see this thing from further away, and there's also something called P-diff waves, which I don't know too much about, but they're special because they've crossed the boundary between the core and the mantle. That's deep down in the underlying features of Mars. So what they've done is they've basically analysed these two shaking events, which are they've got names. I didn't know that they actually named these seismic events. So the 4.2 magnitude is called S0976A, and the 4.1 event is called S1000A. It's a nice round number there. They probably had a celebration for that one, and they were recorded within a month of each other. So sort of similar times. The first one is really interesting because there's enough information in the seismic record that the scientists can actually pinpoint its origin. And guess where it is? I
won't blow the whistle because I already know. I read.
You already know, yeah.
But I was surprised.
Yeah, actually, I was surprised, and then I thought, yeah, that figures.
And people are probably going, "Oh, it was Olympus Mons. It's volcanic," but no.
It's not. It's quite a long way from Olympus Mons. It's Valles Marinaris or Valles Marinaris, depending on how you pronounce your Latin. The mariner, a great cleft in the surface of Mars that dwarfs the Grand Canyon. Absolutely dwarfs it. And yes, so you can imagine that as a feature like that, a geological feature that's of such. It's such a kind of represents a disturbance to the crust, which happened obviously many millennia ago. But there's probably still geological activity there as bits fall down and
Well, I was going to ask if magnitude 4.2 or 4.1 could be caused by a landslide or something.
Yeah, I mean, on a large scale, it could. It's probably more likely a fault because I think Valles Marinaris is actually a fault system. It's a bit like a rift valley where there's faults on either side. And so you've still got fault activity taking place. That's what the suggestion is. whilst the scientists know that the S1000A event, the smaller one, actually did come from the far side of Mars, they can't locate it anywhere near as accurately. And apparently that one, the second one, has a record. It's a record breaker, even though it wasn't the biggest, in that it's the longest recorded on Mars. The seismic activity, the trembling, if you like, lasted for a whopping 94 minutes. It's an hour and a half of earthquake.
Really?
Yeah, it was probably, a bit like the ones on Earth where there's a big shock to start with.
Yeah.
And you get a few seconds perhaps of rapid activity. But then there's aftershocks, there's things that, the vibration decays slowly over time.
That certainly puts to bed the probability of a landslide, doesn't it? I mean, it wouldn't last that long.
Well, no, but if it's a fault shifting or something, it could have that kind of length of time as everything settles down after the initial shock. I'm kind of speculating here because I haven't really seen the close-up details of this, but it is an extraordinary, it's an extraordinary story. And in fact, there's actually a nice quote from a scientist at ETH Zurich, which is, of course, the university that Einstein went to. I'm not sure whether this person was part of the project or not, but what they're highlighting is that the seismic energy that's come actually has passed through something called the core shadow zone. It's where the core of the planet should shadow the seismic waves, but actually what's happening is they're refracted and reflected around as we've had. So this scientist, whose name's Savas Selan, it is one of the co-authors of this project. So it's an authoritative statement. Recording events within the core shadow zone is a real stepping stone for our understanding of Mars. Prior to these two events, the majority of the seismicity was within about 40 degrees distance of InSight. I think that means 40 degrees, as measured on the surface of the planet, as in latitude or longitude. But being within the core shadow, the energy traverses parts of Mars we have never been able to seismologically sample before. So this is, it's new insights. It's really very, very productive in terms of our knowledge. And it highlights what a great project InSight was. To dump a precise seismometer on the surface of Mars, keep it going for, now 4 years, and record the activity. I mean, a lot of what it records is just the vibrations that come from meteorites hitting Mars, but probably also landslides, as we were talking about earlier.
But as for something as big as this, it sounds like something else has probably happened, but there's no tectonic movement.
No, that's right. Sorry, yes, that's
so
the point.
It's not probably been caused by what a lot of earthquakes are caused, like on our planet.
Thank you, Andrew. I meant to say that right at the beginning, and I forgot.
No, that's okay. But if it's not tectonic plate movement or rafts of land crashing into each other or sliding past each other, as is the case on Earth.
Yeah.
What are the theories behind this?
Just this sort of settling that we've been talking about,
or shrinkage, perhaps.
Could be. Yes, that's actually been proposed before as one of the mechanisms for Mars-quakes. You're right.
Yeah.
I'd forgotten that too. Yeah. So, that leads to the conclusion, which is correct, that Mars-quakes are a lot rarer than earthquakes because we've got tectonic activity. Mars's crust is it's like an orange skin. It's an unbroken skin on top of the planet's mantle.
Yeah. Speaking of earthquakes, now that you've mentioned them, I know when there's an earthquake, it's felt significantly in the local area. Those places close to the epicenter with devastating effect sometimes. But do those shock waves radiate around the planet to a point where we don't feel them, but they pass us by? So they go everywhere.
Yes. Yeah. And a lot of them travel within the Earth's, within the body of the Earth itself. And it's because of these refractions and reflections that when you pick them up on the other side of the planet, you can actually work out so much about what's going on inside. It's actually how we know about the structure of our planet, with a core, a mantle, and a crust on top of it. It's not by drilling holes; it's by looking at earthquakes.
Have you ever been in an earthquake, Fred?
Not an earthquake, but certainly I felt earth tremors in Japan, where things wobble. It's not anything alarming. I just remember there's a couple of times I was actually talking to scientists there. We were planning it's a long time ago now, what eventually materialized as the Subaru telescope, which is their 8.2 meter telescope on top of Mauna Kea. And I remember sitting I was on my own in my room in the accommodation I had, and I thought somebody had walked behind me and shaken my chair.
Interesting.
And there was nobody there, of course. And then when I went to bed that night, I was kind of lying in bed just before I went to sleep, and I noticed that there's a lamp that was hanging on a lamp cord. I noticed it was swinging. I couldn't really feel anything, but the lamp was swinging. So.
Yeah. So the building was moving.
Yeah, but I've never experienced an earthquake. What about you, Andrew? Have you been in one?
Yeah, one. 28th of December 1989 in Newcastle.
That one, yes.
Yeah, it wasn't a big one on a global scale, but it was a 5.6 magnitude. But it did cause fatalities and widespread destruction. I'd just finished an overnight shift on a local radio station in Newcastle, and I was at home in bed. And I was abruptly woken up at 10:27 a.m. And it felt to me, because you said it felt like someone was shaking your chair.
Yeah.
It felt to me like somebody had got to the end of the bed and was lifting it up and down rapidly.
Oh, really?
That's what it felt like.
Wow.
I was being bounced up and down on the bed. And I woke up and went, earth tremor. Never felt one of those before. And I went back to sleep. Then my wife rang me. My wife rang me from work and said, there's been an earthquake, people are dead. I said, where? She said, Newcastle. I said, rubbish. Yeah. She said, go and look on the television. And sure enough. And, of course, I had to go to work that night in central Newcastle where all the damage had happened, and I couldn't believe what I was seeing. The railway lines all torn up and twisted, and just buildings down all over the place. It was very eerie, eerie.
Yeah.
And that's the only earthquake I've ever felt. I have been on a volcano that's been doing its eruption thing, and you can feel the quakes through the ground of those small explosions. But they're very scary. And I know a lot of people listening have probably experienced many of them, particularly on the west coast of the US. Mm-hmm. Where they have them regularly. And yes, I can't imagine being in a big, massive one. I would never like to experience that. No. But yes, there's big ones on Mars too, and we'll continue to let you know what they discover about them, because the data they gain may well give us some insight into the secrets of the internal workings of the planet Mars. This is Space Nuts. You're with Andrew Dunkley and Professor Fred Watson. Let's take a little break from the show to tell you about our sponsor, NordVPN. Now, I've told you many times before about good reasons to have a VPN. Security, online security, if you're in a Wi-Fi zone, protecting yourself from hackers, protecting your bank accounts, protecting your personal information. But I thought today I might tell you about one or two things that you might not be aware of that a virtual private network can help you with. Have you heard of traffic shaping? Some people might know it as throttling. This is where your internet service provider basically slows things down so that you're not getting the performance that you expect and that you are paying for as a customer of the service. One of the areas that gets throttled pretty heavily is gaming, online gaming. Now, it's a big thing and a multi-billion-dollar industry. And speed of access to the internet, being able to react to situations while gaming in a real hurry all comes down to how fast your internet service is. Now, a direct connection to your internet service provider means that they have control of your speed, and gaming is an area where things get throttled. Also seems to happen in other areas as well, and you will notice sometimes there'll be buffering. That means you have to wait for the system to catch up so you can keep watching your videos or whatever. So with a VPN, you can bypass that. You can simply connect your VPN service and they can't touch it. That's one area. Another area that I found fascinating is no more targeted ads. You know, when you do a search for something and then all of a sudden you're just constantly bombarded with ads about that thing? If you use a VPN when you're doing your search, no targeted ads. They can't do it. So just a couple of things you probably haven't considered that a VPN can help you with. And there are many, many more. You can look them up online. Just do a search for things people wouldn't consider a VPN to help with or something like that. But yes, and Nord, of course, being one of the best in the business, has very high speeds, and that will keep your service intact, and you can avoid all those kinds of problems. Now, as a Space Nuts audience member, we've got an exclusive deal for you. NordVPN is offering a whole bunch of things. Just go to nordvpn.com/spacenuts. It's a special URL. Use the code SpaceNuts and you'll get a huge discount off NordVPN plus 1 month additional for free, plus a bonus gift. It's completely risk-free too because Nord has a 30-day money-back guarantee. If you want to secure your internet connection, protect yourself from hackers, protect yourself from having your bank accounts cleaned out or your personal information stolen, your identity, for example, or you want to benefit from some of those other things I was just talking about, grab your exclusive NordVPN deal by going to nordvpn.com/spacenuts. Use the code SpaceNuts to get a huge discount off your NordVPN plan plus 1 additional month for free and a bonus gift. It's completely risk-free with Nord's 30-day money-back guarantee. Now back to the show.
Space Nuts.
Now, if you haven't been to our website lately, check it out, spacenutspodcast.com or spacenuts.io. They will all lead you to our website where you can read the news, as in scientific and astronomical news. There's also, of course, the Space Nuts shop where you can buy stickers and shirts and mugs and hoodies and hats and there's beanies, there's socks, there's notebooks, and there are real books. Not mine, Fred's. Fred's got real books. They're all available on the Space Nuts shop at our website, spacenutspodcast.com or spacenuts.io if you would like to check it out. Maybe you've got a birthday or some sort of an event coming up that you're trying to buy someone special a present for. Yeah, that worked. And you're not sure what to get them. Maybe they're into astronomy. Get something from the Space Nut shop. It's your choice, but just letting you know it's available. Haven't spruiked it for a while. Now, Fred, a few things on the agenda for this segment, and one is Artemis. The Artemis mission has been rolled back to the workshop. The poo-foo valve broke, I think.
I think that's what it was, yeah. Yes, it's very disappointing. So this is something we've talked about a couple of times before. Artemis One, which is going to be an uncrewed mission to circumnavigate the moon a bit later in the year, but there was to be a sort of dress rehearsal. It's kind of called a dry launch, but it's actually it's not really. It's a wet launch or a wet dress rehearsal where you load everything up with fuel, get it all ready to go, and that means. And then I think the plan was to stop the countdown at T-7 seconds.
Uh-huh.
So they take it so far, In fact, it's about T-7 seconds that they start igniting the motors on a NASA countdown. So it's been shelved, and in fact, there's been I can't remember what date it was that they brought the spacecraft out to the launch pad. I think it was back at right at the beginning of the month. They've had a succession of problems. We've been sort of covering it for for our listeners, because I think we mentioned it a few weeks ago. But now with problems in particular, I think there's a faulty hydrogen supply. It's a leak that has defied their ability to find out where the hole is. There's also a faulty valve, as you said. The wiffle valve, or whatever it is, has got a fault on it. And there's an issue with the flow of nitrogen to the launch pad. And so basically what's happened is they've said, well, yeah, we've learned stuff from what we've done so far, but we're actually going to pull the spacecraft back to the vehicle assembly building, and it will actually the faults will be rectified, and then they'll pick another date for the wet dress rehearsal, which was supposed to be a 48-hour job. Yes, I've just noticed the date there. It was supposed to be on the 1st of April. Maybe that's one of the problems. A bad day to choose. But anyway, it's now. In fact, I think it is either today or is already back in the vehicle assembly building for the work to be done.
Yeah, wouldn't you hate to be the person responsible for hitting the stop button at T-minus 7 seconds and you slipped?
yeah, that's right. Oh, away it goes.
Oh, sorry.
Right. Yeah.
Nothing to see here.
No, that's right.
All right. Well, I guess that will delay the actual launch, which was due not so far down the track. So
yes, I think they had a launch window from June 29th to July 12th. And that might actually be pushed back now. I think it's still. I think that's still the window, but I think it might be pushed back.
Better to be safe than sorry. Now, we've already talked about Mars, but this story is rather fascinating because it involves the Perseverance Rover, which we've been reporting on in regard to some of the things it's been achieving. But it has taken some rather startling footage of an eclipse.
Indeed. So we've sort of seen pictures of eclipses on Mars before, because Mars has two moons, Phobos and Deimos. They're both much smaller than the moon, neither than our moon. Neither is big enough to cover the sun fully, but they both orbit the planet relatively close by. And so with Phobos, the bigger one, which is all of 23 kilometers in diameter, when it goes by, first of all, it's low down, so it's traveling fast. And secondly, it makes the bigger dark shadow across the sun, or the dark silhouette across the sun, I should say, compared with Deimos, which is much smaller. So yes, Perseverance. The other thing about this story that makes it a bit special is that all the pictures that have been taken of eclipses before by mostly NASA rovers, in fact, maybe entirely NASA rovers, have been pretty low res because they've used their mast cam system. It's a camera on a mast that is used for navigation. Yeah. But Perseverance was fitted with a much higher resolution mast cam, which is zoomable. So it's called mast cam Z, I guess it's called. Mast cam Z, we'd call it here. And the footage from that is just astonishing. So they've captured this little movie, and it's real time. It's a 40-second eclipse, and if you go, the place where I've been looking at it, you won't be surprised to hear, Andrew, is phys.org. They've got a story: NASA's Perseverance Rover captures video of solar eclipse on Mars, and it's there. And it's really worth a look because it brings you the flavour of how different Mars is. There's the sun looking familiar as it does with sunspots on it. I think I might have seen one of those sunspots.
I'm watching it now. It's just started. Yeah. And I'll tell you when it's finished.
Tell us when it's finished as well. Yeah. Yeah. And it is. It shows Phobos is distinctly potato-like shape. I'm playing it as well, Andrew, just because
it looks like someone's hurled a potato past the sun.
Exactly. That's right. But moving, sedately, but pretty rapidly compared with an eclipse that we see on Earth across the sun's disk. And that's the real time. It's not speeded up.
And it's done. That's the whole eclipse in
There
real
you go.
time.
Yeah, that's right. Yeah.
And it's basically going north to south. Ish.
I'm not sure that that's the case. And the problem is with eclipses, you can't make a judgment because it depends on what angle the sun is at relative to the horizon.
Okay.
If it's an early morning eclipse, it does look as though they're going north to south, or a late evening eclipse. So I don't know the details of that, but a really remarkable thing and marvelous footage from the red planet.
Yeah, it's a quick watch. So look it up at phys.org. It's really worth it. Now, moving on to Venus, another near-Earth object, and the common belief is that Venus should be tidally locked to the sun, but it's not. And now they think they've got a theory as to why.
That's right. So, if you think of the moon going around the Earth, the moon always faces the same face towards the Earth, and that's because of this tidal locking process. It's about the gravitational interaction between the Earth and the moon. Likewise, Venus should be tidally locked to the sun because it's near enough. It's actually, I think, just on the edge of where it could be tidally locked, but the thinking would be that it should be tidally locked, but it's not. And that's because, it's not been known why it is. I mean, Venus is peculiar because it rotates in the opposite directions from what it revolves around the sun. And in fact, that's true of Uranus as well. It's why we say, why is Uranus upside down? Although Uranus is only tilted just below its orbital plane. Venus
it rotates like a golf ball. When you hit a golf ball, it has backspin.
That's backspin. It's a very nice way to put it, Andrew. Yeah, that's right. And we don't know why that is. That could have been an impact or something of that sort, but that is the case. It's now thought, though, that what we're seeing here is the effect of something quite different from, disturbances in the early solar system. And that is Venus's atmosphere. That the suggestion, this comes from University of California, Riverside, and I think other institutions as well, that what you've got is an atmosphere on the planet which we know is thick. Its surface pressure is about 100 times what it is here on Earth. It's very hot because it's so near the sun and got this runaway greenhouse effect. But it's also got these huge winds on it. So kind of 400 kilometre an hour winds on Venus, which means that the whole atmosphere travels around Venus once every 4 days, basically. And that's 60 times faster than the planet's rotating. And so the suggestion is that, this significant gas envelope is actually, affecting the revolution. The revolution, it's revolving, of Venus itself. I've got the wrong word there. It's rotation, not revolution. Revolution is it going around the sun. Rotation is the planet's spin. The atmosphere is affecting the spin of the planet. And really interesting, a really interesting take on why Venus is so peculiar.
Yeah, it's interesting because the sun would be cooking up this atmosphere and creating these winds, and as a consequence of that, it's able to escape tidal lock.
Yeah. It's got just enough force to stop the tidal lock being achieved. It's not far off. There is so it's 225 days. For the orbital period, and I think 243 days is the sidereal period. That's the period that rotation is related to the stars, and the net result of that is the day length is 117 days. But so lots, very strange geometry. So it isn't quite tidally locked, and maybe the atmosphere was just enough to stop that.
Yeah, I was just trying to find what the highest wind speed on Earth was ever recorded, and it was April the 12th, 1934, recorded by the Mount Washington Observatory at 231 miles an hour.
Oh, wow.
Which is 372 kilometres an hour.
Yeah.
So that's getting up there towards Venusian speed.
Yes, it is, yeah.
Yeah, I don't know what particularly caused that, but that was in the New Hampshire region of the United States.
Yes.
Fastest wind gust ever recorded on the surface of the Earth.
Didn't know that. That's extraordinary.
I didn't either. I just found it then. I just wanted to make a comparison. But yes, there have been rare occasions where we've hit speeds comparable to Venus.
That's right.
The difference is up there it's constant, isn't it?
That's right, and it's the whole atmosphere that's doing it. You know, and you can see the effect of that. Actually, some of the images that we've seen from some of the spacecraft in orbit around Venus, which have photographed the atmosphere. There's a Japanese one whose name I can't just pick out of my mind at the moment, which shows these curious features. You know, all you're seeing is the top of the cloud deck on Venus, but when you look at it, you see these sort of linear features that go from one end of the planet to the other, which is telling you that this rotation is global. It's not just a local thing.
Is it the Venus Climate Orbiter?
It's not called that. No, it's got a Japanese name. That might be
I can't read Japanese. So.
Well, it probably is then, Andrew. It probably is.
Akatsuki.
That's the one, Akatsuki. Thank you very much.
There you are.
Yeah.
I can read Japanese.
Yeah. I'm going to throw in a curveball here as well.
But it's all Dutch to me, really. Carry on.
No, karaoke, isn't it? Not carry on. The 400 kilometres an hour just reminded me. Did you see that news story about the Czech gentleman who drove his Bugatti along one of the German autobahns at 414 kilometres an hour?
I did not, but
check it out.
I'll be looking forward to seeing him on the next edition of Bad Drivers on Instagram. I love that page.
I've never seen it, but I couldn't believe it. 400 kilometres an hour on an autobahn. It just beggars belief. Anyway, never mind.
How do you keep control?
Well, it was driving the top end Bugatti, so
yes,
it's a
but
car
still,
that probably does. But
I watch Formula One race cars; they don't stay on the track.
No, they don't. That's right, they don't.
Oh dear. Okay. He survived. I guess that's
he did.
That's a good thing.
Yes, he did.
All right, but yes, nothing like they can achieve on on Venus with the winds they've got up there. Maybe they should take an Alka-Seltzer and settle down. This is Space Nuts with Andrew Dunkley and Fred Watson.
3, 2, 1.
Space Nuts.
Now, I've made this request a few times and I don't mind making it again, but after you've listened to us, why not leave a review on whatever the podcast platform is that you use? I'm pleased to be able to say that if you listen via Spotify, they now do allow reviews. So Spotify review would help us a lot. Lots of people have given us reviews on iTunes and Google Podcasts and all those other amazing platforms that carry it. And YouTube's getting really in on the act of podcasts as well. So please leave your reviews on YouTube if you listen to us or, unfortunately, watch us there. Reviews are most welcome, good, bad, or indifferent. Although most of them seem to be pretty good, Fred, but that's probably more about you than it is about me. Now, let's get into some questions. This is a follow-up to something we discussed on episode 300. Unfortunately, I don't know the name of the person, but they'll know who they are.
You recently responded to a question on show 300 of why we couldn't see the center of our galaxy because it was blocked by dust. And my question is, what is the dust? Is it powdered rock? Any idea of the chemical constituency of that dust? Just curious, rather than just dust.
Okay. I think we described it as dirt the other day, Fred. Just dirt. It's a dirty place, the universe. But I suppose that's a fair question. Can we break it down and analyse exactly what's out there blocking our view of the beautiful, bright centre of our galaxy?
We can, yes. And in fact, we know pretty well what it's made of. I've got an old friend and colleague. We were educated together at St Andrews. He's spent his life at Rensselaer Polytechnic, which is in New York State. He has written books on this. It's been his his lifelong topic has been interstellar dust. So I can tell we can say what it's made of, and I'm going to quote. This is actually from a NASA publication back in 1986, where we were already well aware, and of course that comes mostly from spectroscopic work, Andrew. It's what you can do with microwave telescopes, millimeter wave telescopes, infrared telescopes, and I think it was mostly infrared that Doug worked in, and optical telescopes as well. So here it is, a direct quote from this NASA article: "The dust in the diffuse interstellar medium," and that's between us and the galactic center, "consists of a mixture of stardust, which is amorphous silicates, amorphous carbon, polycyclic aromatic hydrocarbons, and graphite, and interstellar medium dust, which is organic refractory material." So that it's basically, a lot of it is silicates. It's stuff that forms just by molecular interactions in these cold clouds of atoms, which turn into molecular clouds. We call them giant molecular clouds. So it's where the raw materials, the atomic raw materials of stuff are located. They've been put there from the atmospheres of stars, which have come to an end, and some have blown up, and some have just drifted their contents into the interstellar medium via what we call planetary nebulae. So you've got all these atoms, which in the molecular clouds, they combine because at cold temperatures, you can get these chemical reactions taking place. And so you get silicates made out of oxygen and silicon. And of course, silicates are what make up rock. And that's the bottom line. It's exactly as our listener suggested, it's powdered rock. But it's only powdered because it's never become rock. It's just the dust that's formed that. And in addition to what we see there, we think a lot of this dust acts as nuclei for other molecules to sit on it, like things that are normally gaseous on Earth. Carbon monoxide. We know carbon monoxide molecules are very common in space. And in fact, the most common two-element molecule in space is water, H2O. So water ice probably covers some of these dust grains as well. And what you've got there is the raw material of comets and planets. So that's the sort of stuff that it is.
Important safety tip: do not inhale.
Yeah, do not inhale. That's right. Especially because you'd only get one molecule per cubic meter or something like that. It's very, very rarefied.
Yeah, I forgot about that. Yes, it is sort of spread out. It's not sort of clustered, but there's so much of it. It still screens our view.
Exactly, that's right. It's very, very rarefied, but huge quantities.
Yeah. So, do we know what sort of area it covers?
What you're talking about, you're talking about things 100 light years across, so bigger. They're not small clouds of stuff, and they've got that. So giant molecular clouds are significant, disturbers of gravity. So if one wanders past our solar system as we are rotating around the galaxy, that's thought to be one of the things that triggers comets to fall in from the Oort cloud to start hitting the center of our solar system.
See, we just thought dust was annoying, but it's actually
dangerous.
It's got a bit more grunt to it as well.
Yes, that's right. Yeah.
All right, thanks for the question. And we've got a sort of a what if scenario. We like to get questions like this occasionally. This comes from Robert.
My name is Robert. I'm from Florida, and I got a question. If the Earth stopped spinning, would we just be continuously dizzy?
Well, we'd probably get thrown against the wall.
Yeah, we might. It's a great question, Robert, and thank you very much for asking that. So the way to think about this is imagine yourself standing on, say, the North Pole, since you're in the Northern Hemisphere, and the Earth's rotating and carrying you with it as you stand at the North Pole, it means you turn around once in 24 hours and then it stops. So you're probably not going to feel very dizzy by that.
Yeah.
It's the motion itself is gentle enough that it doesn't affect. What makes us dizzy is the confusion it's actually all taking place in your ears, isn't it? Those sensors in our ears that determine which way up we are and what the forces we're feeling. That's what makes you dizzy. So it's too slow to have an effect on your sense of balance. But I get the picture. If you spin yourself around and then you stop, you feel really dizzy. But if you spin yourself around once in 24 hours and then stop, you don't really notice it. But of course, it would make the Earth a very different place, and it is going to happen. Actually, it's going to happen unless the sun turns into a red giant star, which means all bets are off. But the way that the Earth and the moon interact, the moon already faces the same side towards the Earth. If enough billions of years can go by without something else happening, then the Earth will always face the moon. And so the Earth will still rotate, but it'll only do it once in 43 days. So it's kind of more or less stationary. That's a situation that we can look forward to, but probably not in anybody's lifetime.
What impact would that then create in regard to the way the sun affects Earth? If we're only rotating once every 4.
So that's right. That's a good question,
days.
Actually. And I mean, assuming the Earth will have probably drifted further from the sun by then. I'm not quite sure which way around this is going, but supposing the sun was at the same distance as it is now, the sun actually raises tides on Earth, and so there would be still a tidal effect from the sun, but it means you'd get a high tide every 21 and a half days.
Oh, right.
Because of that rotation.
But this alteration would happen so slowly, life on Earth would adapt, wouldn't it?
It's happening already, which is why we stick leap seconds into the clocks every few years, because they slow down.
If nothing else cataclysmic happens, like a red giant or any situation like that, we'd adapt. Over time, if we survived long enough to experience this, we would adapt.
We would adapt. Yes, that's right. Yeah. It's slow enough for evolutionary processes to be able to deal with it.
There you go.
Yeah.
I wonder if Robert was also thinking what happens if we suddenly stop rather than get off the spinning object.
Yeah. Well, that's a different scenario.
Yeah, it's like if someone pulled the handbrake, we'd probably, it'd be a global disaster. Everything would be obliterated.
We'd all keep on going eastwards at, in our case here at our latitude in Sydney, about 1,400 kilometres an hour.
Ouch.
Which is much the same, actually, for Florida. It's a bit faster than that in Florida because you're nearer the equator. On the equator, it's 1,600 kilometres an hour.
I find that fascinating, that we're travelling at those kinds of speeds and we just don't know it.
We don't know it, that's right.
Yeah, because we're all going with it. It's all just
everything's going with it.
It's like a fly in an aeroplane, isn't it?
Yes, that's right. It's the same thing, flying an aeroplane.
All right. Robert, thank you so much. Lovely to hear from you. And keep your questions coming in. If you do have a question for us or just want to send us a note, you can do that on our website, spacenutspodcast.com. Down the right-hand side, there's a way of sending audio questions, or you can click on the AMA tab and send audio questions that way, or an email. So spacenutspodcast.com or spacenuts.io to get in touch with us via our various processes and systems. And don't forget to visit us on Facebook as well. Space Nuts, the official Facebook page, is there, and we've got a lot of followers there. But the Space Nuts podcast group is a social media group that Carrie Brown created, and it's just gone from strength to strength. And everybody who joins it get along famously talking about astronomy and space science. And, they do police it very well too, Fred. They don't like infiltrators trying to get in there and, sell clogs or whatever. And they alert me to it very, very quickly. So we do tend to stamp that stuff out real quick. But social media has become a great tool. And we're on TikTok now. I know. As well as Twitter, Instagram, anything else? Might have to join Reddit one day. That's a very interesting community. Anyway, we will leave it there. But once again, Fred, thank you for your insight, and all the information you provide. It's been fantastic, and we'll talk to you again real soon.
Sounds great. Thanks, Andrew. Take care.
See you soon. Fred Watson, astronomer at large, part of the team here on Space Nuts. And, of course, Hugh, back in the studio, who pushes buttons and blows whistles and flicks switches and... he only does it to entertain himself. It's like popping those, that's padding you put in a box. He doesn't actually do anything else, but it's a lot of fun. And from me, Andrew Dunkley, thanks for your company on Space Nuts. We'll catch you again on the very next episode. Bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.